Good morning, everybody. This is our last week of instruction. I had planned to go another week, but the administration thought, well, this week is good enough. There's going to be some alternative assignment or something else next week. I'm going to inform you of what that is. But as it stands for now, next week you're going to have available to make up missing assignments should you need to do so. But that will be up to you. So here we go. Let's look at these problems, and I guarantee to keep this one under 30 minutes today. I saw that last one. It was 45 minutes. No, that was too long. Okay, let's go to problem 2, properties of logarithms. That's what we're looking at here. So we have problem 2, log base 2 of 76.8 minus log base 2 of 1.2. We're going to combine these as a single logarithm. So let me go ahead and make some room by erasing this here. And the rule we're looking at is, it's called the quotient rule of logarithms. If you have the same base of logarithm, but it's a difference of logarithms, this can be rewritten as a single logarithm as log, in this case base 2, of the quotient of 76.8 and 1.2. And then we can use the change of base formula over 1.2 and divide this by the log of 2. So let's go ahead and do that. I see we have concurrent viewers. I haven't seen who you are yet. Let's go ahead and put this in our calculator. We have log of, let me make sure I get the numbers right here, 76.8. Vanch. Okay, good morning. Okay, 76.8. I don't know if I said your name right. Vanch looks like. And I don't recognize the name. I'd be interested in where you're coming to us from today, Vanch. 7th grade. Okay, 7th grade, the Slope Dude video. Fan of Slope Dude. Well, thank you for being here. This is Algebra 2. I suppose you're not in Algebra 2 yet, but, or I don't know if you're working on logarithms yet, but it's never too early to start. And we have Adam here. Adam has really been super dependable all since this lockdown. I appreciate you being here. Well, Vanch, that is just hugely complimentary of you. So anyway, we work this out, we get 6. So 6 is our answer here. What part of the world are you from, Vanch? Are you doing distance learning too, like the most of us here in the United States, the Republic of Texas? And we're going to go on to number 4. Here on number 4, this is really going to be pretty simple because we can use the power property of logarithms, where we can take this, we have this log base 11 of 11 to the power of 23, so we can take this exponent out front like this. America, he's from America, I don't know where America. One time, being from Texas with Texas license plates in my minivan, I was driving with my son through the state, my country of origin, and I said, we're from the Republic of Texas. And he just laughed and just waved us through. Anyway, what you have is log base 11 of 11 cancel out to be 1. And so we're left with 23 as our answer here for problem 4. Okay, very good. Yeah, Google Meet sessions. I haven't used Google Meet yet. I've heard pros and cons of them. I've used the Zoom, but we haven't been allowed to use Zoom at our school. Anyway, here we are at number 6, and we have this more complicated looking expression, log of log base 7 of 98 minus log base 7 of 2 to the power of x. And so we can work this out. When you have the log of something to a power, you can take this exponent out front like this. So we can rewrite this as x log base 7 of 98 minus log base 7 of 2 okay, and we can take, I'm going to put this, hang on a second, I got this, I didn't write everything down. X of log of log base 7 of 98 minus log base 7 of 2, and then we can take this expression here, this log base 7 of 98 minus log base 7 of 2, and rewrite this as x log of log base 7 of 98 divided by 2. So what is 98 divided by 2? Well, I'm going to write this to the side here. 98 divided by 2 is equal to 49. And 49, can we rewrite that as a power of 7? Yes, that is 7 to the power of 2. So we can rewrite this whole expression as x log that's parentheses there, log base 7 of 7 to the power of 2. Okay, and now we can take this 2 out front like this. So we have 2x times log of 1. Well, what do you have? The log base 7 of them cancel each other out, so we end up with Well, the way to do that is not put this out front. I'm getting kind of back here. Just don't put this out front. But what happens is you have the log base 7 and 7 cancel each other out, and you end up with log x log 2. And so that's going to be our answer. And so what we're going to have, when you put that in the calculator, let's just go ahead and put this in the calculator. Log 2 so 0.301, so we get 0.301x is what this amounts to. So that would be our answer to number 6. Okay, now we go to number 8. Okay, I'm going to erase this, what we have here. We have log base 4 of 5 plus log base 4 of 12 minus log base 4 of 3.75. So we have the product and quotient property of logarithms here. So what this is going to be is we can rewrite this as log base 4 of, we're going to have 5 times 12. That's how we combine this using the product property, minus log base 4 of 3.75. And so this is 60, so we can use the quotient property now. So combining as a single logarithm, we can have log base 4 of, we'll have 60 divided by 3.75. And 60 divided by 3.75, I don't know exactly what that is right in my head. 60 divided by 3.75. 16, okay, so that's 16, that's going to be helpful. So equals log base 4 of 16, and 16, I'm just going to go below. Log base 4 of 16, and 16 we can rewrite as 4 squared. Log base 4 of 4 squared. And so the log, you can do it different ways. You can take this 2 out front. I guess I'll do it this way. So equals 2 log base 4 of 4. Well, what is the log base 4 of 4? Well, it's the power. You have to raise 4 to equal 4. What is that going to be? 1. So our answer to this one here is going to be 2. Vanch, do you already, okay, good. Do you already know about logarithms, Vanch, pretty well, or are you just learning, working ahead to Algebra 2? Okay, let's go ahead to number 10. Number 10, we got the difference between the apparent magnitude or brightness m of a star and its absolute magnitude is given by this formula. Little m minus big M equals 5 times log of d over d over 10, where d is the distance star from the Earth, and this is the star rho. Okay, so we have the absolute magnitude is going to be this big M, right? So this is going to be big M. Our apparent magnitude is going to be our little m, and then d is what we're trying to solve for in parsecs. Okay, so we can go to this one here. We have 5, which is little m, minus -4, or -0.4, equals 5 log of d over 10. And so what we have on the left side is 5.4 so 5.4 is log 5 log d over 10, divide by 5. So we have log of d over 10 equals 5.4 over 5. I'm going to just go ahead and calculate that what is, just to make it easier. 5.4 divided by 5 is going to be a reducible at 1.08. I should have known that. 1.08. So now what we can do is we can take the power of both sides, and so we can rewrite this as 10 to the power of log d over 10 equals 10 to the power of 1.08. And so 10 to the power of log base 10 will cancel each other out. So what we have, I'm going to just work over here to the right. So we have d over 10, because 10 and log base 10 cancel each other out, equal 10 to the power of 1.08. And then if we multiply by 10, d is going to be equal to 10 times 10 to the power of 1.08. And what does the property of logarithms tell us that is going to be? You can either just multiply by that, or it's going to be 10 to the 1 power times 10 to the 1.08. So this is going to be 10 to the 2.08 power. So d is going to be equal to 10 to the power of 2.08. And if you didn't catch that, you could have also just made this 10 times 10 to the power of 1.08. You'd have gotten the same thing. So either way, so we get 120.2 So what we say for this one is this planet rho opf is about 120.2 parsecs away. Now, Vance, you know that most of these students that I have here are 10th graders. So that's so I don't know if you're on track to do Algebra 2 by your 10th grader, but you're here obviously, so you're impressing me anyway. So what I have here is 12. That's a sound intensity problem. And what I did here is I'm going to just, I worked this out previously. Oh, we got Abigail. Abigail, I haven't seen from you. You'll be able, Abigail, to catch up and get your grade in a lot better shape. Man, Abigail, I got to tell you, I miss seeing you in class. Seriously. Okay. We have this sound intensity problem. What I did is I worked it all out, and I'm just going to leave it right here. And you can copy this down. You can get to I'm going to move on to the next problem. But you can play this back and look at it if you need to. In pre-calculus next year, those of you going into pre-calculus, most of you I hope, we're going to be working out problems like this during the first semester. Okay, properties of logarithms. Problem 13. Yes, Vanch, I'm a teacher. I'm teaching this case. It's Algebra 2 Honors. And I also teach courses in pre-calculus and calculus. Okay, number 14, we have this one here. Suppose the population of one endangered species decreases at a rate of 4% per year in one habitat. The current population of the species is 143. After how long will the population drop below 30? So what we have is the basic equation for population that we like to say is P of t is equal to the starting population, P sub 0, times the base, which is defined as 1 plus r to the power of t. And here we have r is equal to negative 4%, or negative 0.04 for base is going to be 1 plus negative 0.04, or 0.96. And we're giving our P is equal to our starting amount, which is 143 P sub 0. So 143 we have times 1, or I said 1, but 0.096 to the power of t. Now in 13.3, which we came from most recently, we would have solved this by graphing using just in the calculator, but here we're using the title, Properties of Logarithms, to solve this. So we go ahead and work out the we're going to divide by 143. So that cancels out. So we have 0.96 to the power of t is equal to 30 over 143. And so we can get rid of this t by taking the logarithm of both sides. So if we make this log of 0.96 to the power of t, that's going to be equal to, doing the same thing on the right side, log of 30 over 143. I see we have another viewer here. Sketch with style. Good to see you, Sketch with style. And now we can move this t out front of 30 over 143. I'm curious, Sketch, of where you come from. Okay, so now we can solve by t by dividing both sides by log of 0.96. So that cancels out. So I'm going to just work up to the right here. So we get t is equal to log of 30 over 143 divided by log of 0.96. So t is going to be approximately equal to what we put in the calculator. So log. So we have log of 30 over 143, and we divide that out by log of 0.96. Okay, very good. Let's go ahead and press enter. So we get 38.26, we'll call it rounded. So about 38.26. So let's go ahead and take that answer. After how long will the population drop below 30? We'll say after about 38.3 years. All right. Ladies and gentlemen, I told you today that I was going to keep this thing at 30 minutes, and we're just right about there. I just will go quickly to number 16. And number 16, I previously worked out. So this is the solution right here, and we're going to be doing this in pre-calculus next year. So I'm just going to leave it right here, and you can copy that right now. I'll just leave it here for a couple minutes. Hydrogen ion concentration and pH value. I hope you're working with that in chemistry. Yeah, these are real world applications we're looking at here. And so I'll just leave it here for a couple minutes, give you a chance to copy, give you a chance to say goodbye. I'm really glad that for Vanch and Sketch showing up. Abigail, I gotta say, Abigail, it's really great to see you here. And Adam, as usual. Awesome. And you'll be hearing from me, my students, via Remind, what's going to be on tap for next week. It's not going to be another assignment like this from my class. So I'll let you know when I know, and I'll give Abigail and anybody else the chance to use next week to make up and get your grade up looking real good. That's what we want. Okay, with that, everybody, thanks for coming, and I will see you later, I hope. Take care. Bye-bye.